So now I'm going to discuss about the cases of elastic collision. Cases of elastic collision. Cases of elastic collision, right? So now I'm going to discuss I'll be discussing two cases in this video, and I've divided this four cases. There are four cases into two videos. The two cases that I'll be discussing in this video. The first is the case that I'm going to frame here is that M1 is equals to M2 is equals to M. What you can consider through this written form. We know that, wait for a while, right? Which means that mass 1, the masses of two boxes are equal, right? This is mass 1 and this is mass 2, right? So masses are equal. For a while, consider that this is moving with a velocity u1 and this is moving with a velocity of u2, right? This is moving with the velocity of u2. Then this is moving with the velocity of v1 and this moving with the velocity of v2, right? So when these two bodies collide with each other, this space mean here it collides with each other, right? I'm sorry, in this region, right? So what happened to the bodies? The question arises that what happens with the bodies of same masses when they collide with each other. Masses when they collide with each other. So that we can easily find out with the help of an example. This is okay, so I'm going to do this here. The first equation that I'm going to find here is, let's do it. V1 is equals to, we need bracket for it, M1. This is basically equation through which we can find out easily whether the body is in rest, moving in u1 velocity, u2 velocity, or bouncing or something like that. We can calculate it. We don't need to write the busy and long formulas for finding out the equation. That we have a very short pattern or a short trick to find out immediately or quickly, right? So the next one is M1 minus M2, right? And that the here bracket as well. I forgot to put the bracket here so that you put in yours by yourself. I'm sorry. So this whole equation will be multiplied by u1. Okay. So again, the other equation that I'm going to write here is that plus, sorry, again bracket 2 m2 u2 and then divided by m1 m1 plus m2 bracket close, right? So this is equation something like that. So here we are pretty aware that the masses, I'm going to change the color here, yeah. So we are aware that the mass 1 is equals to mass 2, which mean, and it's equals to m, which mean masses are equal. So the written or the frame condition we can easily interpret that that this will going to be 0, and if it's 0 divided by a number, which means 0. So we know that the v1 is equals to 0 plus, there is no need to write 0, but I'm writing it so that it will be easy to understand, right? So we know that the masses are equal here. So again, this mass, wait, this mass and this mass cancel this mass, and the only equation that going to remain here is that, wait, is v1 is equals to u2. So what's the interpretation here, right? That v1 is equals to u2. Let me show you that. What does it mean? It means that when two bodies, let me move up, let's move up to understand this. What does it mean? It means that when two bodies of same masses collide with each other, they only transfer their velocities into other body, despite it's in rest or it's moving or it's in motion, right? If its v1 velocity become u2, then it's pretty obvious that its v2 velocity become u1. So that we can show with the help of formula as well. Here I'm writing the formula. I don't need to write formula. Okay, I'm writing here. So it will be easy for you to understand. V2 is equals to bracket m2 minus m1, then bracket close, divided by m1 plus m2 bracket close, then plus bracket 2m1 u1 divided by m1 plus m2. Right, this is something like this. Right, so we know that the masses are equal. I'm sorry. Okay, okay, so as we know that the masses are equal here, so this equation masses are equal here, right? So this equation will gonna cancel, this whole equation will be cancelled 0, and m1 mass cancels m1 mass, to m mass only u1 remains, right? So though this we can easily write here that v2 is equals to u1, v2 is equals to u1, right? If two bodies of same masses collide with each other, they transfer their velocities into each other. How we can interpret this? Wait, let me show you. This was moving with the velocity u1, this body moving with the velocity u2, right? I'm sorry. After a while, its v1 velocity will become u2 and its velocity become v1, which means they have transferred their velocity into each other despite they are in rest or any other condition, but the masses of the boxes are same here. So we can write here the final equation that is here is that when two body of same masses collide with each other, the v1 velocity will be equal to u2 and their v2 velocity is equals to u1. So this is the case 1. Now I'm going to discuss the other case here. Let's move down for it, or I can remove it as well. It's good. Now this is case 2. Case 2. Case 2. And what's the the condition I'm gonna frame here is that m1 is the same condition, only one difference, m2 is equals to m, but here u2 is equals to 0. What does it mean? It means that here the final u2 velocity of a body is 0, which means it's in rest, right? So again we can take two boxes here, so it will be easy for you to understand it. For example, we have one box here, the same box, right? So sorry, I'm so sorry. These boxes, they are these boxes, right? Wait. Okay, so the masses of boxes are again same, which is m1, m2 is equals to m1. No, this is m1. The masses are same, which means there is no change in mass. Only velocity changes. This is u1. Okay, this is u2. This is v1, and this is v2. But here, as you can see that here, its u2 velocity is equals to 0, which means body is at rest. This body is at rest. So what will happen when this body collides with this body? As we know that the masses are same, so they transfer the velocities into each other. So if u2 is 0, so v1 velocity has to be 0. So that we can check with the help of formula as well. It is in rest right now. Rest. Sorry. Okay, so let's write equation here of v1. v1 is equals to um, v1 plus v2 divided by m1 plus m2. I'm sorry, m1 plus m2 divided by m1 minus m2 bracket close, right, plus m1 this right. So 2 m2 u2 divided by m1 plus m2 and then the bracket close again. As we know that the m1 is equals to m2 is equals to m, as one more condition that we have considered is that u2 is equals to 0. If u2 is equals to 0, we know that this full equation will be equals to 0 because u2 is 0 and masses are equal. So what will gonna happen here is that its initial velocity v1 will be equals to, we know that the masses are equal as well, so it will be 0 as well. 0 plus 0 is equals to 0. So here we have gotten the answer that v1 is equals to 0. And yes, it's a predicted answer that I said you here that here the u2 velocity is 0, which means it transfers its velocity into each other when they collide with each other, right? So here the initial velocity is also 0. So the condition is proved here. Now I'm going to talk about the v2 velocity here. Um, v2 is equals to the bracket and then we got to write here. Okay, so this is the bracket. This is m2 minus m1 divided by m1 plus m2 and then the bracket closed and then the bracket closed plus m1 to m1 u1 divided by m1 plus m2 and again the bracket closed. As we know that the u2 velocity is here 0. So this whole value will be going to be the whole value is going to be, wait a minute, I guess I have mistaken, this is plus, consider it as plus, this is m1 plus m2. Okay, as we know that here the masses are equal, so if masses are equal this equation is going to be 0. Okay, and this mass cancel this mass, so v2 is ultimately equals to v1 u1. As you can see here, v2 is equals to u1, which means that here the v1 velocity is 0 but u2 velocity is equals to u1. So this is proved as, yeah.